Right, linear and non-linear simultaneous equations, the process is always the same. You take the non-linear one and you substitute it into the linear one. What am I saying? You take the linear one, you substitute it into the non-linear one, right? Except in this case, you've actually got y equals and y equals. So if y equals 3x squared and y equals 2x plus 5, then it follows logically that 3x squared must equal 2x plus 5. And therefore, we've got a slightly simpler question now. We just rearrange to make a quadratic by subtracting the 2x and the 5 from both sides. And if we're cunning, we can factorize this, but we can't assume that we can, so I'm just going to go for the formula. We've got a is 3, b is 2, sorry, negative 2, c is negative 5. B squared, what's negative 2 squared? It's not negative 4, it's 4. 4ac is 3 times negative 5, which is negative 15 times 4 is negative 60, which makes b squared minus 4ac. Oh, this would have factorized. 4, take away negative 60, so 64. So we got x equals a negative b plus or minus the square root of b squared minus 4ac, then divided all by 2a. And of course the square root of 64 is 8, so that leaves us with 2 plus 9 minus 8 over 6, which is going to be 10 over 6, or minus 6 over 6, which is equal to 1 2/3, or minus 1. Now, we're not quite done yet. Obviously, we need to work out what y is. So y is, the easiest one to work with is y equals 3x squared. If x is 1 2/3, y is going to be equal to 3 times 1 2/3 squared, which is going to be 25 3 to 8 1/3. Or it's going to be 3, y is equal to 3x squared, is going to be 3 times minus 1 squared, which is going to be 3 times 1, which is going to be 3. Now, very important, you need to write the results in pairs. When x is 1 2/3, y is 8 1/3, so that's one pair. And they need to be written together. If you don't do this, you lose marks. And when x is minus 1, y is 3. So having written them in pairs, we've solved the question, and that's it.